Composite functions are embedded functions, and they follow a certain flow through the function flowchart. So just a reminder that when we look at a composite function, there's an inside function. Okay, so there's an inside G and the outside F. It's going to go from inside to outside. So when we put an X through that function, we end up going through G first. We get an output for G. Then we go through the F. And then we're going to end up with our output, which is our range. And if we go in this direction, we have the regular function. In the opposite direction, we're talking about the inverse function. So using our mapping diagrams, and we can use this kind of flow chart as well, we can evaluate some of these terms. So if we take a look at the functions here, there's f, g, h, and u, and make note that u is going from right to left instead of left to right. So when we take a look at the function h and the input is x, our output is going to be m. So we have m as our output for h of x. The g function is down here. If we input c into our g function, our output is going to be y. The u function is going from right to left, but this means the inverse of u. So if we put that going in the opposite direction, if our input is y, our output is n. Here we have an embedded function. So we're going to first apply the f function, then the h function. So our input for f is going to be b. So the output will be x. We're going to put that output of x into the h function, and we get an output of m. Okay. For the inverse of g, so take a look at g instead of going in this direction. Okay, so we're going to start from the inside first. So look at the u function. So we start with n. Our output is y, and we're going to use the inverse, so we're going to go in this direction for g. So we input y, our output is going to be c. So the last question here is asking, what is the problem with trying to evaluate the inverse of the inverse of f of the inverse of h of m? Well, the inverse of h is going to be this one here, and we start with m, we're going to end up with x. No problem there. The f is going from inverse is going to go in this direction. Now the problem with trying to evaluate the second stage of this, the inverse of f, is that when we input x, there are two possible outputs. So the inverse of f is not a function. Because we have two possible outputs here when we inverse the f, and so we're dealing with a non-function.